Hello everyone, hope everyone is safe at home. Firstly, I would like to welcome you all to this RK Vision YouTube channel. This is Lakshmi and I am here to teach mathematics. So, today I am going to start with the chapter 1, that is number system. So students, can anyone say what is exactly a number system? Yes, well, a number is a mathematical object that is used to count, measure as well as label. Suppose if you are having a number of books or it may be a number of chocolates, for counting each one we are going to deal with a number system, or for measuring the quantity of an object we are also going to deal with a number system. For labeling the parts of an object we are going to deal with the number system. Here the original examples are the natural numbers, that is which are starting with 1. All counting numbers are said to be natural numbers. Just later we will discuss that one. Well, here 1, 2, 3 and so on up to infinity, that are the natural numbers which are examples for the number system. And it can be, that is a notational symbol that represents a number is called what? Numeral. Here a notational symbol which is representing a number, it is said to be a numeral. So before starting with an exercise, let's have a look on the types of the number system. Just now we have discussed with the definition of the number system. Let's look on the types of the number system. So we're having different types of a number system. The first one is natural numbers, that is all counting numbers. Counting numbers are called natural numbers. So I can say all the counting numbers which are starting with 1 are said to be natural numbers. Usually the natural numbers are starting with what? 1. 1, 2, 3, so on up to infinity are said to be a natural numbers. And the set of elements are represented by using a capital letter N. Here the set of numbers which are represented by using a capital letter N, and the elements that can be represented within a flare bracket, which are starting with 1, 2, 3 and so on up to infinity. These set of numbers are called what? Natural numbers. And the next one, whole numbers. Whole numbers. So I can say all the natural numbers including with 0. With 0 together are said to be a whole numbers. Natural numbers with 0 together are called what? Are called whole numbers. So students, keep in mind that here the word itself will say. So what is whole? If I hide the word W, we can see the H whole, isn't it? Suppose if we are adding 0 to the natural numbers, then the set of numbers are said to be what? Whole numbers. Here the whole numbers can be represented by using a capital letter W. And the set of elements are starting with 0 including natural numbers. This set of numbers are said to be what? Whole numbers. So, and the next type is integer. So, integers are said to be a collection of whole numbers as well as negative numbers. So, if we are going to add negative numbers to a whole numbers, the set of numbers are said to be an integer. Here, the integer can be represented by using a capital Z or else capital I. So, here, if you observe the set of elements, we are having the whole numbers as well as the negative numbers. So, which is starting with -3, -2, -1, 0, 1, 2, 3. So then set of these numbers are said to be what? Integers. And the next one is rational numbers. So always keep in mind, students, a rational numbers can be expressed in the form of numerator by denominator, where numerator should not be equals to denominator. In the same how denominator should not be equals to 0. That is, a number can be expressed in the form of p by q. That is numerator by denominator, where p and q are integers. Here the both numerator and denominator should be integers. In the same how p should not be equals to 0 and q should not be equals to 0. That is, p should not be equals to q as well as q should not be equals to 0. Here the set of rational numbers can be represented by using the capital letter Q. And these are all the examples for rational numbers. So rational numbers are nothing but numerator by denominator. That is 1 by 2, minus 5 by 7, 3 by 7 and so on. So always keep in mind, every integer is a rational number. So all the integers we can say it as a rational numbers. The next type is irrational numbers. So here the numbers cannot be in the form of p by q. In the same how p should not be equals to q and q should not be equals to 0. So a number that cannot be expressed in the form of p by q, where p and q are integers. In the meanwhile, p should not be equals to q as well as q should not be equals to 0. Here the set of numbers can be represented by using a capital letter Q dash. So since we have used the capital letter Q for rational numbers, here irrational numbers is exactly opposite to that of rational numbers. That is why I am denoting it as Q dash. And the examples for Q dash are root 2, root 3, pi and so on up to. Here it is nothing but it will be having a decimal representation. Now come to the next one, real numbers. Here the collection of rational numbers as well as irrational numbers are said to be what? Real numbers. See, the collection of rational as well as irrational numbers together are called real numbers. Here the real numbers which will be having a both rational as well as irrational numbers. It can be a number in the form of p by q, it can be a decimal representation, and it can be a whole number, and it can be natural numbers also. Let's have a quick view on real numbers. So what did it say? A real number is a combination, that is a collection of rational as well as irrational number, isn't it? So if I am going to represent a natural number by using a capital letter N, so it will be having, this circle will be having a set of natural numbers, that is starting with 1, 2, 3 and so on up to infinity. If I am going to add 0 to a natural numbers, so here the natural numbers which will be having what? 1, 2, 3 and so on up to infinity. Suppose if I am going to add 0 to a natural numbers, then the set of numbers are said to be what? Whole numbers. W is said to be what? Whole numbers. So if you observe here, the whole numbers is having 0 including 1, 2, 3. Suppose if I am going to add negative numbers to a whole numbers, then set of numbers are said to be what? Integers. That is, suppose if I am going to add minus 3, minus 2, minus 1 to this set of numbers, then the set of numbers are said to be what? Integers. That can be represented as a capital Z. Suppose if I am going to add a numbers will be in the form of p by q, that is numerator by denominator to a integers, then the set of numbers are said to be what? Rational numbers. So 1 by 2, minus 3 by 7, minus 1 by 4. So then these set of numbers are said to be what? Rational number, isn't it? So this set of these numbers are said to be what? Rational numbers. So the numbers which are not the rational numbers are said to be what? Irrational numbers. The numbers which are not the rational numbers are said to be irrational numbers. So for example, we can give root 2, root 3, pi, etc. Now, the collection of both rational as well as irrational numbers are said to be what? Real numbers. So, it is said to be a real numbers. So, our real numbers can be a collection of both rational as well as irrational numbers. So, and the next one is decimal representation of a rational number. So, always keep in mind that a rational number is either terminating decimal or non-terminating but recurring. So, what is meant by terminating or non-terminating? Suppose if you are taking an example 1 by 2. The value of 1 by 2 is what? 0.5. So, if you observe after the decimal we are not having any after the decimal point we are not having any continuation with the digit, isn't it? So it is exactly starting with 5, that is 0.5. This is said to be a terminating. Suppose if you are having the value, so if you are having 0, 3, 1, 4, 5, 6, this is said to be a non-terminating. If after the decimal point, if the values are keep on moving, that is said to be non-terminating. Well, so it is a number either terminating or non-terminating but recurring. Recurring is nothing but repeated values. So, next come to the recurring decimals are also expressed as what did I say just before? Recurring is nothing but what? Repeated values. So, suppose if you are having the value that is 0.555 can be expressed as 0.5 bar. So, if you observe after the decimal point, the decimals that is 5 is repeated how many times? 3 times. So, since 5 is repeated continuously, we can express it as 5 bar. We do not put the bar for whole the number, that is 0.5. For the whole 0.5 we cannot put the bar. Only for 5 we have to put the bar because 5 is repeating continuously. In the same house 0.7878. Since 78 is repeating continuously, we have to put the bar for 78. In the same house 0.213213. The bar should be kept for 213. In the same house 0.8929. Here again 0.8929 bar. That is a bar should be kept for 8929. So, and the next one is decimal representation of a irrational numbers. Always keep in mind that the decimal representation of the irrational number can be either terminating or non-terminating. Well, the decimal expansion of irrational number is non-terminating, non-recurring. Moreover, a number whose decimal expansion is non-terminating, non-recurring is a irrational numbers. Always keep in mind that it will be non-terminating, non-recurring. Non-recurring in the sense the numbers will not be continuously repeating here. Well, the next one is rationalizing factor. When the product of two irrational numbers is a rational number, then each of them is called rationalizing factor of the other. Let's take an example, that is 2 root 3 into root 3. Since we are having root 3 twice, that it will becomes root 3 whole square. Here the 2 and root will get cancelled, square root will get cancelled, the remaining values will be 2 into 3, that is 6. So obviously I can say that 6 is a rational number and root 3 is called rationalizing factor of 2 root 3. In this chapter we are having a small topic regarding the exponents. So I have written the formulas for exponents. So if m and n are rational numbers and a is a positive integers. So if you observe this, you can remember the previous class. In the last year we have already discussed with the exponents, isn't it? The same rules we are going to use once again here. So we are having a power n into a power n. So here the m and n are said to be index or power or exponent, and a is said to be a base. So if you are having the same base, then the powers of the same base are going to be added. That is a power m plus n. In the same how, a power m by a power n. Since we are having the same base, but here we are having the division of the powers, therefore the powers are going to be separated. That is a power m minus n. In the same how, a into b whole power m. If you observe, we are having two different bases, therefore the power is going to be multiplied for the both bases. That is a power m into a b power m. That is a power m into b power m. Suppose a power minus m can be written as 1 by a power m. In the same how, a power m whole power n can be written as, since we are having two different powers, the powers of the same base can be multiplied. That is, we are having only a single base, therefore the different powers going to be multiplied here. That is a power m into n. In the same how, a power m whole power 1 by n can be written as a power m into 1 is m divided by n. In the same how, a power m by b power n. If you observe, we are having two different bases with a single power. Therefore, we can write it as a by b whole power m. In the same how, nth root of y can be written as y power 1 by n. Suppose square root of y can be written as y power 1 by 2. In the meanwhile, nth root of y can be written as what? Y power 1 by n. So, in the next class, we'll just start with the exercise problems. Till that, stay safe, stay home.